sore kungaphela amandla.
Welcome back, everyone. Um, I'm dedicating this song to you guys as you have come to almost the end of the journey. You have worked hard, and I can imagine the dedication that you have put to finally get here. The song is basically stating it's all up to you. Everything is on you. As you can see, other people are hustling, other people are working hard, and someday a miracle or your day will come where things align, where you finally within the career you wanted. Maybe you're finally driving that car and you have that house and you're doing all the things you always wanted and have worked for. And all it takes is just dedication and prayer and yes, all that you find as a journey into getting what you want. So again, welcome back. Today we're going to be discussing the Kaggle competition. I hope you guys have seen it. Um, it is not part of your assessments that are going to be within a mark, but more of a challenge to extend on your knowledge and what you have learned, make it more fun, make it more competitive as well. But before we jump into that, we know the rules of engagement. If you have any questions, if you have any questions, post them on the Q&A section. Feel free to use the chat liberally and respectfully. And lastly, make sure you listen, learn, and engage. Right, again, I'm your host. It has been an honor taking you through the ML track and up until the end. I hope I helped to some extent, but I'm really proud to be seeing everyone I've seen from the beginning up until now. So, a question I have for you is, what is one important lesson your data science journey has taught you so far? So in the chats, remember that rules of engagement says use the chat liberally and respectfully, as well as engage. What is one important lesson your data science journey has taught you so far? I'll give you a moment when maybe you're still typing. One thing I've learned with the journey with you guys is that you guys are really dedicated. And it makes us happy as the people who have been walking through or going through this journey with you to see the dedication, to see the effort that you put in. It truly is admirable. Trying till you get it right, Petunia. Yes, that's resilience is the one thing that will get you through life. I always vouch for resilience. Never assume that just one thing goes wrong and you're like, oh no, this is not for me. No, I'm still doing it again. And if I have to do it 10 times, I will do it until I get it right. There's a there's a saying in my language that says, angeke ngihlulwe into engahambi or into engaphili, meaning I won't be defeated by something that doesn't walk or is alive or talking. So in any challenge, keep going, keep trying. At some point, you're gonna get it. And you guys got it. You've made it up until here. You've worked hard, and now all that work is paying off. Is Petunia the only one who's going to respond? Being wrong is part of the process. Exactly. I love the fact that you guys are not stating, oh no, I enjoy, but understanding the obstacles you faced. Basically, help or what's the word? Enhance growth. When you know the challenges you faced and know how you approach that challenge, when you face another challenge in the next day or tomorrow or in the next season of your life, you won't be faced as much as you were when you first met a challenge of this nature. Now you know that when you're going to learn or acquire a new skill, yes, it may look hard in the beginning, but oh, come on. I've been here, I've done it before, I've stumbled before, and I got up and I did the work and I accomplished it. Working towards solving the problem, then building complex looking projects. Exactly. You've now developed the skill of not just the tool of Python and Google Sheets and SQL and predicting models or building predictive models, but you now understand the skill of solving a problem. It is okay not to understand everything now. Yes, that is very true, Shagan. Things won't just make sense immediately. Things happen and you're just like, okay, wow. But this is never the end. It's never the end. You still have a chance. You still have the opportunity, even now. Take these words, take this wisdom that you have now obtained during the obstacles you have faced into your next season of learning, whether you're acquiring a new skill, whether it's just personal life. Make sure that, you know what, as Shagan has said, it's okay not to understand everything now, but time, dedication, hard work will always get you to where you want to be. All the journey as DS was really outstanding and all the lessons are very important, but I enjoyed more in ML, especially NLP chapter. Oh, ML, I'm pretty sure I enjoyed it because it was probably the most complex. A lot of learners would get there and I'd be like, oh my gosh, what's going on? And the last question I have for you guys, which is a question I always asked you, from a scale of 1 to 10, where are we now in the understanding of machine learning now in general? Not just unsupervised learning, not supervised learning, but where are we now? Whoa! uh Adibuwale, 3. Hectic. The last time I was with you guys, we had 9s and 10s. But that's okay. It's still a learning journey. You're still here. Christine is at a 4. I can't pronounce this name. Maruane is at 6. I've decided that I'm good as a data analyst and not a data scientist. Okay. Okay, Petunia. Um, self self-knowledge and self-recognition is also good. I'm glad we managed to get that out of you as well. But as long as you're in the data world, we're happy to have you here. Kanya is at a 9.999. I wonder what that 0.001 is. Togoza's at a 7. Okay. Well, as stated, baby steps. It's a learning journey. Even we, as your technical mentors and data scientists, are always learning something new every day and are also facing different challenges. So the last challenge, well, not the last challenge, the second last challenge, but a challenge that now brings everything together is the Kaggle competition. Petunia, that is fine, but keep learning data science. It might come in handy someday. That is true, Shagan. That is very true. So one of the challenges, or yes, challenges of competition we have is the Kaggle competition. And as stated, it's not for marks. We don't want to put in that pressure. You've had so many assessments where you had to make sure you score above 50%. But now this is for you. This is for you to now take in everything that you have learned up until now and apply it into a real world scenario, all up from pre-processing the data, EDA, up until predicting a model, in this case, a recommender system. So first things first, what is a recommender system? Who can give me an example of recommender systems they've come across? We see it in everyday life. What recommender system have you come across? Netflix, true. Very, oh, Spotify. Spotify has a good recommender system. I don't know how, but the music They recommend to me every time I play a specific genre is on point. YouTube, yes. Ads, yes. Is that a is ads or you talking about specific ads in a streaming platform, okay? Amazon. I've never actually used Amazon, so I haven't really experienced that recommended targeted ads, yes. Spam emails. Oh, yes, yes. Hmm? Yes. One as well is Google Maps. See how now it recommends location for home, work, school, right? Timu. I think I don't, Timu's just going wild. Timu is everywhere at this point. It's in my emails, it's in my social media. You Google something, Timu's there. I don't know who they paid, but wow. People you may know on Facebook, yes. Oh, the recommender system on social media is intense, especially TikTok. Yesterday, I liked a Michael Jackson video, right? So now that's something that's trending at the moment since his movie just came out and also a documentary. And I liked one video. And after that, I saw nothing but Michael Jackson. The conspiracy theories, the um those who imitate him, the dance challenges, the oh wow, those algorithms are intense. But yes, those are examples of recommender systems. They're a type of machine learning system that predicts and suggests items to users based on their preferences, behavior, or similarities with other user or items. So, maintain some of the recommender systems we have collaborative filtering. So this is user behavior of many users. So users like you like this. So for instance, example, if you are a user who lives in South Africa, so you see how I'm not sure whether in every other country, but I think Netflix does do that. So if I'm in South Africa, it gives me the top 10 watched movies in South Africa. Right. So that's one of the collaborative filtering uh recommendation systems. You can have content-based filtering. Now, this is the one that I just stated. User item features. So if you like this item, so here are similar ones. I like the Michael Jackson video, and then boom. All I got was Michael Jackson videos moving forward. Then we have combine or hybrid system. This is a combined collaborative and content base. So this improves accuracy because it doesn't just recommend for you, it recommends based on people who are similar. So maybe you could have conversations as well about, oh, like what's the trending movie right now? Office Romance, I think. I'm not sure if it's trending in any other country, but yeah, definitely trending in my country. It's a good movie. You should definitely try to watch it. So there are some challenges with recommender systems, right? Just like when you're building any model, there you always face some challenges that you may need to address. One is a cold start problem. This is when you basically have a new user and maybe the one thing you can allocate to them is their country. So this is when the system cannot make good recommendation because it has little or no data about a new user or a new item. If a new item comes in and no one has watched it, there's no rating. You're not sure if you should recommend it to this specific user or not. Then you have data sparsity, where the user item interaction matrix has very few observed values compared to the total possible interactions, such as your few clicks and few ratings. We also have balancing, whether you want to balance the accuracy versus the diversity. So with accuracy, it's recommending items the user is very likely to engage with, and diversity is recommending a variety of different or less obvious items. I think I would prefer diversity. Like, yes, it was interesting to see a Michael Jackson movie, but I am on this platform to just kind of get entertained by not just one story or one storyline and so forth. Lastly, scalability is the ability to efficiently handle very large numbers. So you can imagine how many users Netflix has. I'm pretty sure everyone here on this call has a Netflix account, or maybe most of you. Now you can imagine how that data looks like, or how much the matrix, right? How that looks like. So the ability to efficiently handle very large number of user items and interaction is definitely a challenge for some recommendation systems. Now, another matrix that you'll see with recommender system is your cosine similarity. So this is a matrix to basically help understand maybe how similar this user is to the other, or how similar is this item to the item that this user has rated and liked. And how do we interpret it? So if we're comparing two values, say value A and B, we'll use the cosine similarity. Obviously, there've been specific values that have been given for, let's say, a movie in comedy and a movie in mm, rom-com. Okay, maybe they've been given a rating. So how would we see whether these items are similar? We would then use cosine similarity, and how we interpret it is that if the value is close to 1, that means these items are very similar, or these users are very similar. If it's close to 0, definitely not similar, or what we call orthogonal. And if it's close to -1, it is opposite direction. So rare in typical recommender or text use cases. Right, so we have our matrix, we have our challenges, and we have some of the methods we can use for our recommender system. So in this Kaggle competition, what you are going to be building is a movie recommender system. And before you start with it, you are going to have to set up a Kaggle account. So we've attached the link for you. And once you click that link, hopefully you can still see my screen. There we go. Once you click that link, okay, I have obviously set up my account. It will prompt you to set up an account. You'll select whether you want to set up using Gmail or a different email. And then I'm sure you guys have set up an account. You did it when you were working on Athena. So same process. Once you're done with that, you can then go to the Kaggle competition. Okay, I don't know why it stopped sharing. Sorry. Where is it now? I can't find my Google. What's going on? Did my Chrome just close? Sorry, give me 2 seconds. I don't know what happened. Yeah, I don't know what's going on now. Yes, my Chrome just completely shut down on me. And now I'm looking for my slides. What happened? Apologies for the technical issue. Just open that. Share my screen. Right. So you're going to select the Kaggle competition link. Okay, hopefully it doesn't just exit again. There we go. So once you select the link, it's going to automatically take you to the Kaggle competition. Just giving it a moment to load. Can you guys still hear me? Okay. Right. So it's going to take you to this page here where you have your movie recommendation. It gives you a description. Please do read through the description, and most importantly, the format in which you need to submit your code. Right, so let's look at what the description says. In today's technology or socially, so just sorry about that. Okay, so it just basically gives you a brief on what you're going to be working with. Uh, Ever wondered how Netflix, Amazon, Showmax works? It's not just a guess drawn out from that, there's an algorithm behind that. So what value is achieved through building a functional recommender system? And then the evaluation. So the evaluation matrix that's going to be used to evaluate your recommender system is the root mean squared error. All right, you guys remember that. Okay. So we're going to be using RMSE to evaluate how well your recommender system works. Then submission format. This is what you want to submit. For every author in the dataset, submission files should contain two columns. You have an ID and rating, where ID is concatenated of the user ID and movie ID given in the test file, right? So please note that there's data that you're going to download, and you have every description of the files that you're going to be supplied with, correct? A score mapping the strength between movies, user assigned tags for genome related sources, your IMDb, additional information that below is provided directly from Movie Lens dataset. And it just gives you a description of some of the columns that each of the dataset contains. Please go through this, all right? How are you going to download this? You have 9 files that you can download. So you can select or state download all, and it will download all your files. If you count, you have 2. Oh, can this thing stop showing? 2, 4, 6, 8, 9. So in order to download all these, you'll say download all. Now you're going to use them for building your predictive model. Please note that you have been given a train and test dataset. So you don't need to perform the zero or do the 080 separation for train and test data. You have been given that train and test data. Right. Then you're also going to be given a starter code, which is in the slides. You can create a new notebook here where you can code on, sorry, the platform of Kaggle. Just waiting for it to open. My. Right. So you'll run this code, and then from there on, you'll keep adding a code cell for whichever code now you want to add. Maybe you want to pre-process the data. Okay, you know that what's working or your Kaggle files. Let me see. It should have all the files there. So then you're going to use a path for you to get your files. It will be provided with for you in the starter notebook in case you want to code in on Kaggle. Okay, but if you want to code on Jupyter Notebook on your personal PC, please note that you then have to download this dataset and then call through the file on Jupyter, or if you're using VS Code, and run it on your PC. Please, you also have to remember that your notebook has to be in the same folder as this dataset, right? Or you can call the path name, would just be longer, but it's more ideal to have your notebook in the same folder as your dataset. Right. So now let's take a look at our starter notebook. If I can just locate it, because now, so you're going to be given a link, and it's going to take you to Google Colab, and where you can then run your notebook and work through. So you've been given, let me open the one I had, but it's the same thing. You just download it. This has been ran. You download it. It has the libraries that you'll need. The surprise package is for recommender systems. All right. So sorry, just give me a moment since my Google Chrome closed. I just want to open my Jupyter. Um, where are we? What's going on? Today is not the day, Anaconda. Be doing what you're doing. There we go. Download movie recommender system, and you have it. Give it. There we go. Right. So basically, this notebook is just to get you started on everything that you're going to need for the recommender system and some guidance. All right. So if you run, so as you can see, it's the same code as the one on Google Colab. I had already downloaded the data set and have it in my folder for me to run it. So if you have, or once you run this cell of code and it has surprise, it may not run because you did not install your surprise tool, surprise library. So please make sure that you run this code first. Let me clear my kernel. Please make sure that you run this guy first. All right. And this one here, just in case once you start installing the packages or calling the packages and it doesn't run. These are issues that some learners came across. And so we've made sure that this time you guys have the right packages installed. So as you can see, there's a list of packages you're going to install. Hopefully you remember most of these packages or all of them, correct? Maybe something new might be the surprise package, but not really. You guys have worked on these packages, right? You have your NumPy, your pandas, your processing, your make blocks. We've given you all possible libraries that you could need. You may not use all of them. You may not use all of them, but as stated, it is a starter notebook so that you can navigate what you need and what you don't need. Right. So let's run that. Cool. Then we start reading the data. Remember, we had the train, the movie, and the IMDb as well. Not sure why I don't have the Kaggle. I'm sure it's here. There we go. So if you're going to be running it on Kaggle, this is where you can select or run this line of code to access those different data sets. Right, you'd have Kaggle input, ALX movie recommendation project. In this case, it would say 2026. Make sure to correct that. Just change it to 2026. And it reads all of those data sets, your test, your links, your tags, your genome scores, and sample submissions. So these are all this data set here. Note this is when you are running it on Kaggle. Okay, if you run it on your PC, it's not going to run. You're going to get an error. If we run it, you'll see. Right, so I've ran my libraries. As you can see, it ran. It didn't give me any error. That is because I had already installed these two packages. So if we run it, we're going to get an error. Give it a moment. Okay, so it states Kaggle input ALX recommendation systems. There is no such file or directory. You're going to get an error. It doesn't exist in your personal PC, but it exists within Kaggle platform. All right. Cool. So I'm just going to remove that for now. But the notebook, once you download it, will have it. You choose whether you want to use that directory within Kaggle or you want to use it within your personal PC, of which you would have downloaded it. In this case, if you look here, I have all my files in one notebook. I mean, in one folder. Okay. So if we run that now, hopefully I don't get an error. All right, great. Now I've imported my data. I've imported the train, the movies, and the IMB dataset. And as of usual, up until now, we all know you don't just run and work through the project or work through building a recommender system. You need to understand what type of data you're working with. So you guys remember that head function allows you to see those first five rows of a specific data set. In this case, with movie ID, noting that, okay, we want to build a predictor, a recommendation system that will recommend a specific movie to a new user who hasn't probably watched it. Right, so we have a movie ID, we have a title. The title shows the name of the movie and the year. Maybe, just a suggestion, you could separate it. You could have title and year. You have genres as well. Each genre separated by a straight line or that line, straight dash, and I'm not sure what they call it. You have adventure, animation, children, comedy, fantasy for Toy Story. You can separate those genres as well. So you need to understand what you're working with and what will help your model perform well, right? You guys remember, we've been working through ML. We know how certain models are sensitive to specific data. Am I going to create dummy variables? Am I going to use your TF-IDF vector? TF-IDF vector, yes, right? So understanding your data helps you see, okay, what do I want to work with? What am I not going to work with? Let's see if how can we get these links you're using? So which the Kaggle, they're in the notebook, the links for the datasets are in the notebook that is going to be provided with you with the slides. Okay, please note, I repeat, you only use hopefully this when you are running your notebook on Kaggle. Okay, if you run it on your PC, it's going to give you an error. Cool. Also, seeing the shape, so we know we have 62,423 rows. Correct? That is the shape of our data, and we have 3 columns: your movie ID, your title, and your genre. And we see we have a large data set. So data having the recommended challenge of not having enough data or too little data is definitely not a problem here. So first things first, look at your data, look at what you're working with, look at the features that you're working with, correct? We've done this. Has been the core concept of machine learning. Before I build any model, I need to understand what I'm working with. Thereafter, I perform EDA. What does EDA contain or mean? We have your outliers. You need to understand if I have outliers. What hasn't been mentioned here? Well, let me hide. Who can tell me some of the EDA processes that you need to perform before building your model? So in the chats, are you there? EDA. What does that entail? What do I need to do? I already saw you have outliers, okay? There's one. There's that one. Null, yes. Null or missing values. Very important. Okay, how am I going to perform mean or median imputation? Right, so make sure you apply EDA where you identify outliers or detecting outliers and then handling those outliers. So you want to decide, am I going to keep them? Are they of use? Are they going to skew my predictions? Right. Then understanding relationships between various attributes and structure of your data. So remember we had correlation analysis. You can build a correlation heat map to see which of these features are correlated. Do I have a linear relationship between these features? Do I have is there multicollinearity? Maybe I want to use, I don't know, linear regression. Okay. But that may not work. You have to make sure, okay, correlation is not working. Let's use some visualization techniques. What can I spot from my data? Right? You know, if you want to see the distribution of your data and how it moves, is you use a scatter plot. Then also understanding the data structure. So including the distribution of values and the presence of any values. So this will help you identify, am I going to keep this outlier? Am I going to remove this outlier? So it's very important to understand your data more than you understand how a predictive model works. Then you start recognizing the important features. So if you use techniques like random forest, gradient boosting, or sharp values to determine feature importance, domain knowledge, statistical tests. Okay. Hope you guys still remember those. We also remember we went through not hyperparameter, dimensionality reduction as well. Maybe you could apply that just to reduce what could this project or this competition is basically to help you take everything in without the pressure of having the mark to it or passing or deadlines and so forth. There's no deadline. You guys take your time, but just at least try the competition and see what have I learned? Can I apply it in a real world scenario where everything now needs to become brought in and applied? So with the train and all the data set, you can use the following line of code to check whether you have any missing values. So from the current data that I have in the train, oh, what error is that? Test DF not defined. So I have not imported my test DF. Let's import that. DF is equal to, and we'll say test CSV, I'm sure. No, run that. Hopefully all others are there and see if that has any null values. Which one? Links. This is the fun part about coding. What did we call it? Links DF. Let's input that links and let's call DF is equal to, what is it called? Links CSV. So we'll say links CSV. We run and see whether or not we have any missing values. And no, well, for links in TMDBID, we have 107 missing values within that column in our links data. With our IMDB, we have multiple missing data in different columns, right? So we want to make sure, what are we going to do with this? That's a lot of missing data. So what are you going to do? Going to remove it? Are you going to replace it with the mean or median? You need to now decide. We've given you the tools to see whether or not is that a good idea or is it not a good idea. Just want to now. And the 4DF is equal to, I need to see, was it just genome scores or tags that it's looking for? And scores or scores? Scores. Don't see an error. Am I typing it right? Okay, no, we're good. Great. So you want to see, what am I going to do? It's not defined. Genome scores, genome tags. Right, so genome scores is not defined. Let's look through that error. Did we call it genome scores or genome DF? So I'm guessing it's genome scores. You guys can see what I'm doing. So just in case it tells you that a specific variable has not been defined, it means that maybe not, you may have not imported that data. So I'm probably going to get another error for genome tags. Exactly. So now that's your homework, to go and input genome tags and import that data. Right, but as you can see, we do have some missing values. And now you need to decide, okay, great. Now I've went through my data, you know, go through visualizations to see the distribution. Are there any outliers? What am I working with? So for now, we know that we have missing values. Go create the visual of scatter plots to see if you have any outliers. Give us a summary of your statistics. Understand, oh, okay, do I have a mean runtime? Let's say for IMDb, what's the mean runtime? Understand your data. Do as much analysis as you can. You can never do too much, especially when performing EDA. You want to make sure you understand your data well. Then comes data preparation. So this is when we are preparing our data for our model. So we have collected the data, we've read through it, we see the missing values, we now start cleaning our data. Are we removing outliers? Are we removing the missing values? Are we performing mean or median not amputation, imputation? There's labeling. So you saw how we had, where is it? Title. My title came with Toy Story and the year it was made. Maybe I can separate them and then change it to title and year. That is part of data preparation. Prepare your data so that your model will perform well. There's also transforming your data. This includes normalization, scaling, right? So you can use standard scaler or min-max scaler, depending obviously on your data. Which one is more appropriate? Do I have a specific range that I want my scale to fall under? Or is it just fine to use my standard scaler where I have a mean of 0 and a standard deviation of 1? Then there's exploring. Analyze the data to understand its structures and relationships. This includes descriptive statistics. What are your descriptive statistics? Your minimum value, your first quartile, your second quartile, your third quartile, max, standard deviation, mean, right? Those are your descriptive statistics, your count. So that helps prepare your data. And lastly, visualizing, as I stated multiple times. Maybe if the data in itself doesn't tell you that much, then create a visual so you can see how is it distributed. Create a scatter plot to see how is my data moving, right? Again, you can do this by viewing your data. As the title, we've done that. You see your train with your test data and your train data, you see that you have user um user ID, movie ID, rating, and a timestamp. And your test is user ID, and movie ID. Correct. So you can create data frame. That's why we had pandas as well, where you store movie genres and you have a column movie ID and movie genres, taking from the column movies DF and so forth, right? So you can split genres separated by that line and create a list containing the genres allocated to each movie. Okay. Then you can create expanded data frame where each movie genre combination is a separate row. So for example, let's look at what that looks like. So now we have movie ID. And as you see, this is the first movie. That's your Toy Story. What did we have? We had adventure, animation, children, comedy, fantasy. So if you look at movie ID 1, what's that? We have Toy Story. So each movie ID in its genres will be represented in different rows. So it knows if the model performs, it knows that with movie ID, it fell into animation. With movie ID 1, it fell into adventure, animation, children, comedy, fantasy. It all knows that these genres fall under movie ID 1. Rather than having it in one row where it's separated by this punctuation there, it's not sure what's happening there, right? Maybe you could have used NLP and say, okay, let's tokenize the specific row. Multiple ways, different ways, but you need to make sure you use the one that will help your model perform better. Right. Now performing the visuals. With now that we now see that each movie ID has been allocated to its own genre by row, we can create a visual to help me see. How is my data of genres distributed? As we can see, oh, why is this in such a small output block? Right, we see that most of the movies have the genre drama, then comedy, then thriller. So we have our top three. Okay, we also have romance, action, and so forth. And the last one would be IMAX, film, noir, or musical. Not shocked that musical's there at the bottom. I'm not a fan either. But now I understand how my movies have been distributed. Most of the ones that I'm working with are drama, comedy, or thriller. Cool. So suppose we have now worked and I've now removed the outliers or kept the outliers, maybe they are useful. I've either removed the missing values or I have substituted them with a mean or a median. I've performed some sort of transformation. I've separated my columns. For instance, with the genre, we've separated the genres, and now maybe I have a column of year and title. And now my data seems well enough so that I can go into the modeling phase. So remember with what we are building a recommender system. So you need to apply one that we had stated in the beginning. We either have content-based or the collaborative method. Am I going to use the content-based method where I give each user or I recommend an item to a user based on what they have liked or what they have clicked on or what they have rated? Okay. Or am I going to use collaborative method? So similar users, so therefore I'm going to give them similar items. So let's run that. We're going to run and import more. And please note you do have this notebook. So everything that I'm running through now, you have it. We're going to run. We have these libraries here, but just to make sure, we're going to run our pandas as a surprise, reader, dataset, SVD, and accuracy. Right. So now your reader library is basically defines a rating format. Okay. So it helps if you see with where's the one? Here. Train, we have our rating. So maybe if you're going to use content-based method or filtering, the rating could help, right? Could help see, okay, no, they rated this movie 4 and it was from this genre. Maybe that could help. Okay, now let's run this guy. Oh, we've run it before. So I'm going to give an example with a books data. Okay, I can't necessarily build the content or collaborative method for you because then you're just going to use it. We want you to apply it. So let's take an example of a books data. We have books with ID 1, 2, 3, 4, 5, 6, 7, and each have a title to Kill a Bird, 1984, The Great Gatsby, and so forth. All right, so we have 7 book IDs and 7 books. I'm going to put that into a data frame. And then we look at what that data frame looks like. Right, so we have book ID and we have title. Now let's also create user profile for each of these books. So this is us building the Netflix. Okay, that's the Netflix. It has no rating. It's just ID and title. Then we create some sample user profiles. So for each book ID, our user 1 and 2 has given a rating for each book they have read. So for book ID 1 or for user 1, the book IDs they've read is 2, 3, and 4. So what's 2, 3, and 4? 2, 3, and 4 is To Kill a Mockingbird. I don't know why I keep saying board. Mockingbird. And there was 2, 3, and 4, or read 2, 3, and 4. That's 1984, The Great Gatsby, Pride and Prejudice. Great. Then user 2, they've read 1, 3, and 5, and they gave a rating of 4, 5, and 3. In this case, the highest rating is 5. So let's run that. Now we're going to combine user profiles into data frame as well. Look at the data. I don't know why I didn't write that down so we can see. Oh, no, man. What am I doing? Read ratings DF. Ratings if. Right. So now we have user ID, book ID, and rating. So the same way, if you note what we had done with, when did we separate this guy here? We have each ID has its genre. Each movie ID had its genre. In this case, each user, so we have user 1 and user 2, goes along with their book ID and their rating. Now let's build and evaluate our model. So in this case, we don't have a train and test split. Remember, with Kaggle, you have been given your train and test data. So we're going to have a train set and test set, and we're going to separate it to 20 to 80. We're going to use the SVD model. We're going to perform those predictions, and we're going to have a root mean squared error and read and predict from there how is it performing. Just give me 2 seconds. Just wanna run that. Okay, yes. Keeps changing. Oh, that's because we haven't. Remember, who can tell me why my root mean squared error keeps changing? In the chat, who can tell me why my root mean squared error keeps changing? Set seed. Yes. Is it set seed or random state? Well, Vincent random state. Yes. Okay. When did I see set seed again? Was it on R Studio? Or does it also apply? Yeah. Right. So we haven't set our random state. So please make sure you set your random state. You know, the one that we've always used is 40. What is it? 40, 42 is the one we mostly use, but obviously you can select your own as well. So now we have built and evaluated our model and our root mean squared error. Remember, this root mean squared error is not like your R squared error. It doesn't state, it's not a percentage. You need to look at the value. So now in this case, what are we predicting? We are predicting the rate that this user would give to this new book. All right. So we are predicting for user 2 to read, or the book ID 3, which they could give rating 5, and the estimated is 3.68. User 1 as well, same thing. Remember, we have 10 and test. We have the real rating and the estimated. Right, so this is book, not book. This is user 2, user 1. Recommended book from the model is ID 3 and ID 3, book ID 3. The real rate that the user ID had given was 5 and 4, and the predicted or estimated from the model is 3.68 and 3.79. All right. Now let's build, excuse me, a collaborative recommendation. So collaborative recommendation will be based on, let's say we're assuming that user 1 and user 2 are similar users. And from there, we're going to build a collaborative filtering method. So this is the function here. If you run through this function, this is what is going to be giving us our predictions. We have user ID, the recommended book, the predicted rating, and the actual rating. Once you run this, so if you want to perform collaborative filtering method, we have given you that code to do that here. All right. So let's look at how this model is performing, or how our method is performing. We have user ID, we have a predicted rating, and an actual rating. The recommended book was 1984, and predicted rating is 4.19, whereas the actual rating they'd given us is 5.0. Remember, we're working with train and test, so we do actually have the actual rating. So how would you say this model is performing? We also have some none values, some missing values as well. Should we have removed them? Should we have kept them? How is this model performing well, not so well? In the chat, who can tell me whether this model is performing well or not? Anonymous in the Q&A. So this project is not graded on our side, but how you are going to be evaluated is by the value of your root mean squared error. So the model with the lowest root mean squared error will be the best performing model. I'll show you as we go by. So once we're done here, we'll hop onto Kaggle so you can see. Hopefully there's some submissions there. So in the chat, who can tell, who can state, is this model performing well? Is this collaborative filtering recommendation doing well? No, yes. How are these predictions looking? Well, maybe we should leave it. Excuse me. Is there anyone here? Not so well. Yes, I also wouldn't say not so well. So take it a step further and use apply now root mean squared error to see whether this is it how are my errors looking? If the root mean squared error is low, please note you need to take into consideration the unit of your values. So in this case, if my root mean squared error is 0.9389, it's about close to 1 unit difference from what I would have or what I have predicted to the actual value, right? That's the difference between the errors. Is it too big? No. If we're working from units of 0 to 5, in this case, or 1 to 5, depending on your rating, that's not too bad. So go and check the root mean squared error of this performance. And then see, okay, maybe this is performing well, or maybe it's not performing well. But from what we're looking at the moment, it's not so great. We have some missing values. We can't really state whether or not. So what, let's suppose we have an actual Netflix. What are we going to do with this guy? Like this is a predicted rating, but we're not really sure because they never gave us a rating, correct? We're not really sure. Cool. Then generating your outputs here. Remember, what do they ask when you want your submission or the submission that you have? Remember, let me see here. Where is it? Let's go back. Your submission is ID is concatenation of the user ID and movie ID given in the test file. So you need to make sure you concatenate those two where you'll have user ID and movie ID concatenated by a dash. So here we have 1-2 2011. So this is the user ID and this is the movie ID joint. So concatenated is joint by an underscore. And rating is the predicted rating for a given user movie pair. All right, so in this case, so for example here, what does it look like? Let me show you. I think I have now submissions to CSV. Let's see in my file folder. We now have submissions.csv. What do we have? If we open that, we have ID and predict. So this is what you have to submit. All right. Then let me see. I want to show you on the grading. So before we hop onto the grading, let's quickly go through some quick tips. Read the description well. I mentioned this in the beginning. Understand what you're being asked. Also, remember to concatenate and the evaluation matrix that we're going to be looking at. Sampling is your friend. Start small and scale up. Data ingestion, please ensure the correct path is dependent on the environment. Ensure test output matches dimension of test for Kaggle submission. You have 20 submissions per day. This is an individual project. Remember, we want you to test your knowledge of what you have learned up until now. Never mind this. Ensure, I think, yes, no. Please do ensure that your email correlates to the Athena for effective tracking. Not necessarily effective tracking, but if you have a question on, let's say, with one of your projects and you made a submission, at least once you're asking me on answer base, I can track that email as well to your submission on Kaggle. Okay, so make sure you use a shuffle, ensure test output aligns with test sample ordering. Okay, for randomness, make sure your notebook is in the same folder, analyze your data well, and make sure you have gone through your content. All right, so everything that you are testing here and maybe a bit of extension, you have it in your content. So with regards to how the competition would be graded, submissions. Okay, these are my submissions. Just want to leaderboard. Right, as you can see, they're all basically number one, but this is their root mean squared error. So we want to check which one has the lowest. And as you see, number 2 has 0.79. Number, let me see what's happening here. Entries, oh no. But okay, there we go. 1, 1, 1, 1, 1, 1, 1, 1, 1, up until number, where's that 0.79? Up until 18, everyone had the same root mean squared error. Then we had 19 at 0.79, 20 also at 0.79, 22. So you want to make sure you reduce your root mean squared error to be at the top of the leaderboard. Does that make sense? I hope it does. I'm seeing the Q&A again. I think there's something. Where is the link to the notebook to be used? It will be provided in the slides. The link to the notebook to be used will be provided in the slides. As you see, it's the same notebook I've been working in. You're going to now save file and then download that notebook. Reminder, if you're going to run this notebook in your personal PC, download the data. So from here, let's repeat that process again. Let me just remove this guy. You go to data, you scroll down, and you'll see download all. That will download all these files here, right? Then you use and make sure that your notebook is in the same folder as this data set so that you can use, let me use specifically this one. You can use this line of code. So once you want to read everything, you're just going to remove that here. Let me see. Maybe not able to edit that guy because I have to download. No, I don't have it there anymore. But you could just remove this part of the directory like that. Put it back for those of you like that. And then if it's in your folder, you just run that. You just remove the Kaggle extension of the ALX movie recommendation pod. So you'd remove it up until here and then run it on your PC. See if I missed anything. So as you can see here, if you want to run, you'll say new notebook if you want to run it on Kaggle. If you go to models, there aren't any models I've built, discussions, no discussions yet. You'd see the leaderboard, who is leading, rules. Oh, when you do create your profile, you will be asked to accept the rules. So it's sort of an agreement that you're going to adhere to the rules of the hackathon, that this is an individual submission. Okay. If you're in a team, in this case, you're not in a team, it's an individual, then submissions, it will show you the number of, or each of the submissions that you've had. You will get an error if you do not submit in this format here, where you have the user ID and movie ID concatenated by an underscore and the rating. You will get an error. It can't read what's happening. Okay, it will be looking for these columns with entries that look like that. Cool. See, are there any questions? As I stated, the link will be shared with the slides. So the link for the notebook will be shared with the slides, of which then you can import your data. It has the libraries. It gives you an example of building a collaborative filtering method for your recommender system. Are there any other questions? So definitely please share your project via GitHub and LinkedIn with the hashtag ALX Project Portfolio. Definitely can't wait to see what you guys are working with and the thought process of everything you have learned and how you are applying it to the specific project. Again, understand your data. Your data is important. All right. Are there any questions? As for now, let me quickly launch the poll. Where's this guy? Okay, a poll has been launched. Please do complete the poll before you leave. And if there are any questions, I'm still here to take any. You can post them in the Q&A section. I don't see any at the moment. I guess you guys are good and ready for to attempt the competition. I really hope you try it. Just give it your best. You're applying your skills. Even in working with this project or challenge, you are still learning. You don't have to, it may not click, but it is a learning process. So please do try it just for extending or building more insight on what you have learned up until now. Right, so you guys know our technical support. We have the ALX data programs team. This is on eHub. So this is the eHub community space where you can ask any program or content related space questions. Please use this space only for this purpose. We also have Fresh Desk. This is the go-to space for all program support. Ensure you log a ticket with the support team before you approach the program team. And Answer Base, this is where you find me and all other technical mentors. This is the channel specially dedicated for you to ask and get answers to complex content questions. A reminder, please, when you do have a question you want to ask based on code that's not running, please send us a screenshot of your code and the error that you have so we can give a more clear solution to your problem. Right, your assessment or Kaggle competition is due next week on the 15th of June. The office hour recording for this week has been shared on eHub. Find our session recordings and resource on the program hub space on eHub. Graduation is coming up in 2 weeks. Aren't you guys excited? Submit any pending variables or assessments before then. Remember, you are not alone in the community. Engage with your squads, ask for clarity, and post your wins, challenges, and new insights on your squad spaces. Again, really proud of you guys for making it up until here. I really hope we have helped you through this journey in enhancing your skill in data science and specifically machine learning. And I really hope you guys try this Kaggle competition just to see how much more you can do from what you have learned. Until then, we'll see you next week, and I hope you have a lovely week. Also, there is Shagan, if you can confirm for me, please. Is there an office hour on Friday for the Kaggle competition? So try and attempt it during this week, and then on Friday, Shagan, are you here? All right. We'll make sure there's an announcement on whether we're going to have an office hour for the Kaggle competition. So for those of you who are going to attempt it, please note that we'll have an office hour for any questions you may have, errors you may be facing in your code that we can help you with. So definitely try and attempt it. And then if a learner struggles to submit all pending tasks for this cohort, can such a learner join cohort 11 and graduate normally? Um, I think the last cohort has already started running, John. That is cohort 10 machine learning has already started running. Unfortunately, we have moved into self-paced. So maybe look into applying for self-paced data science, as we won't have a cohort 11 ML track. Let me check. No, there's no cohort 11. There's just 10, which is already running. All right. Hope you guys have a lovely weekend. Enjoy the rest of your week and all the best with the competition. And we'll see you in the office hour on Friday. We will help you address any issues you're facing while attempting the project. See you next week and have a lovely day.